No need to fight tonight.
Assalamualaikum. This project, we have to design and determine the suitable pipe network to supply water into Parcel A that contain 8 residential educational buildings, 4-story building, and we assume each floor will be 70%. They also have cafeteria and also admin building. So we have to determine the firefighting flow and peak flow to find critical flow. The size of the reservoir will be constructed based on the pipeline design and also flow scenario.
Next, we will continue with proposed pipe network. This is our proposed loop pipe layout. For pipe equivalent length determination, we neglect the presence of minor losses in the pipe network. For 1.3, the platform level is the reduced level plus 0 elevation. The value of 0.2 was the depth of the pipe buried at the underwater level of 200 mm. For 1.4, it shows the water demand at draw-off nodes. What we have here are the demand and peak flow for the hostel, GEC, AD, DF, and H. Not to forget cafeteria block K and admin block J.
The calculation for flow scenario, we have to find out the critical value that consider both peak flow and firefighting flow. So this is the calculation on how to get the peak flow. The firefighting flow depends on the type of building and its surrounding. This is a table that shows the class risk. So the most suitable one is class B risk. Since the fire flow value is greater than peak flow, we will be using a fire flow as our design flow.
This picture shows us the correction tabular organization of loops and pipes. The size of the pipe that we use is D equal to 200 mm and 230 mm. So we will use the Heisenberg equation to complete up the calculation as shown in the picture. For constant K, we will neglect the small losses in each pipe since they are not in the same length. These are the formula to determine the head loss due to friction based on Heisenberg equation and to determine the value of correction flow in pipe of assumed Q.
We continue the 3.5 assume trial flow in pipe. For this part, we use HBM method. The Q value we just assuming. H value we got from based on the equations 3.4, which is H equals to K times Q power of N. And for this method, we need to get the H value is equal to 0. Since the first iterations I didn't get H is equal to 0, so I make another iterations, which is second iteration, but I didn't get H equal to 0 also. So I make the iterations until 5 iterations. Move to part 3.6, calculation of residual at draw-off nodes. We use Heisenberg equations. For the H node, based on the formula H node equal to H res plus TWL minus VWL divided by 2. For example, node B, the reduced level that we get is 43.5, and the H node that we get is 63.3, and the HF we take from the HBM table. For the value H, we just minus the H node value with the HF value, so we will get the value of H. TWL, we will get the value from the table above. As for the residual HL plus with H node, we minus with TWL, and we will get the value of residual heat. Move to part 3.7. Came for another flow scenario. Based on our calculation, remaining water head value is greater than 7.6 meters because 7.6 meter is the minimum remaining head value. For it is stable and mathematically sufficient to distribute the water to the household, there are no other flow conditions. So meet the end parcel and be developed in the future. We move to part 4, which is summary of the design. For summary design pipe size, based on our calculation on part 3, the diameter of the pipeline will not bring any deficiency or huge loss on the pipeline system. This is because the remaining head value of all nodes are greater than 7.6 meters, and we can assume that the diameter of 200 mm and 230 mm of pipeline can deliver the water to the user successfully. We also recommend that to increase the pipe size to meet the higher demands. And for the reservoir design, we decide to use a stainless steel water tank. This is because we want to avoid the rise and to affect the quality of treated water. and the size of the storage tank is 63,000 mm times with 44,000 mm times with 28,000 mm, which is equivalent to the daily volume of 77616.0 meter cubic. That's all for me. Thank you.